Audio Jungle. Audio Jungle.
So thermal efficiency, right? Thermal efficiency already you have seen when I explained the thermodynamic cycle for turbojet engine. So that was Breton cycle, and from Breton cycle you had seen the that equation eta Ts thermal efficiency, and it was 1 minus 1 upon Rp to power gamma minus 1 by gamma. So whatever the thermal efficiency you had seen, okay, from Breton cycle, so that is correct one, no problem. But here we are going to write this thermal, okay, so you already have seen this equation 1 upon 1 by Rp to power gamma minus 1 by gamma. This formula you already have seen, where Rp is nothing but compressor pressure ratio, which is P2 by P1. That is already I have explained in last session. Now this one is correct, but this is in terms of the pressure at the station 1 and 2 pressure if you know, or temperature you know, anything, temperature or pressure if you know, then you can calculate thermal efficiency. That is one thing. But how to relate this thermal efficiency with the mass flow rate of the fuel, with the mass flow rate of the air, with the velocity at exit of the nozzle, or what is the aircraft speed? If you all component, if you want to relate with the thermal efficiency, then again you need to write one more formula for. So this one is correct, no doubt, but I told you this formula will work when there is the pressure ratio or when there is the temperature at each and every station, okay. But second formula also you have thermal efficiency. Don't get confused like when formula, what formula when will be used. So I told you this thermal efficiency formula will be used when you know the pressure ratio of the compressor P2 by P1 or Rp. If you know, directly you can use and calculate this. Or temperature at the inlet and exit of the compressor if you know, then you can calculate this Rp value, and then finally you will get the thermal efficiency, that you know, okay. Second formula I'm going to give here. Thermal efficiency is the efficiency of energy conversion within the power plant itself. How and what energy conversion? I told you, in combustion chamber or in combustor, what you are going to do? Simply you are going to burn the products. What products? In combustion chamber you are going to inject mass flow rate of the fuel. I means fuel you will inject, and the air is what coming from inlet. Air and fuel, when it will mix in combustion chamber, and if you ignite, so that combustion will start, okay. So here the energy conversion is simply, you can say, that chemical energy, whatever the fuel you are going to inject in combustion chamber, that is chemical, okay. So chemical, obviously chemical will have a chemical energy in the form. So once you will start burning, so that chemical energy will be converting into thermal energy, yes or no. So that's the reason it is said thermal efficiency is the efficiency of energy conversion within the power plant itself. So it is considered as an internal efficiency, while the propulsive efficiency resembles an external efficiency. Okay, so that also need to remember why the propulsive efficiency considered as the external efficiency, because there you had seen what is the thrust power output divided by what is the propulsive power. Yes or no? So that was related to the output of the engine directly. But here the thermal efficiency is not related to the output power. It is related to the what energy conversion is what going on in combustion chamber. Hence it is called internal efficiency. So thermal efficiency in the formula, if I say, so it is nothing but eta T H. Eta T H, it is nothing but directly formula I will write power imparted power imparted to engine airflow okay, divided by rate of energy rate of energy supplied in the fuel. So this is the formula of the thermal efficiency. Just like a propulsive power formula was output power, thrust power divided by propulsive power. Yes or no? So similarly here, this thermal efficiency is power imparted to the engine airflow divided by rate of energy supplied in the fuel. So if this is the, you can say this is the engine of the aircraft. Okay, this is the engine of the aircraft. So I can consider these 2 points. I can consider these 2 points here. Okay, here obviously we have a mass flow rate of air, and what is the inlet velocity? It is V infinity, which is also called free stream velocity or aircraft velocity, right? And somewhere in between there is the combustion chamber. You say this is what combustion chamber or combustor CC, and here you are injecting, or you can say burning amount of the fuel. So rate of energy supplied in the fuel. So what is the energy supplied here in terms of fuel? Okay, because you are burning, so definitely energy will be supplied. So here you can say rate of supplied in the fuel. Okay, it is nothing but mass flow rate of the fuel into H value. Sometimes in few books it is given CV, calorific value, or HV, which is called heat value. So that heat value or calorific value, HV or CV, meaning is same. It is depending on the types of the fuel, what type of fuel you are using for. So heat value for that fuel will be there. Okay, it will be given to you. Okay, so heat value is what depending on the fuel types of the fuels. It's a fuel property, you can say MF. And if combustion chamber efficiency is given, then you have to say eta cc, you need to multiply. That will be the rate of energy supplied in the fuel. So that next I'll tell you. I'm considering combustion chamber is 100% perfect. So m dot f into hv will be the total energy which is supplied in the fuel. Okay, and that fuel will burn in combustion chamber. Okay, so and here you will have a exit. This is what exit. Okay, and exit is what gas, which is nothing but m dot a plus m dot f. Now it becomes gas, and what is the velocity here? It is exit velocity. All right, so what is the power imparted? What is the power imparted? Power imparted to engine airflow. Power imparted is, it is nothing but rate of kinetic energy is nothing but power, right? What is the rate of kinetic energy? It is nothing but power. So what is the power imparted to engine airflow? It is nothing but 1 by 2 at exit. What is the mass flow rate? Check in the diagram. It is m dot a plus m dot f. So what is the kinetic energy? M dot a, m dot f at the exit, half mv square minus m dot a at the inlet. It is nothing but m dot a v infinity square. So this rate of kinetic energy is nothing but rate of kinetic energy is nothing but power. Okay, so m dot a plus m dot f, because it is mass flow, mass is not mass, actually it's a mass flow rate, hence it is called rate of kinetic energy. So now that's what will be the eta th. So eta th will be the power imported to the engine airflow, which is nothing but 1 by 2 uh, m dot a plus m dot f ve minus 1 by 2 m dot a v infinity square, okay, divided by what is the equivalent amount of the energy supplied to the fuel. It is m dot f into hv. I told you hv is nothing but, I need to write somewhere, hv is nothing but heat value, or in few books it is given calorific value, okay, so there should not be any confusion, heat value or calorific value. Heat value hv or cv meaning is same, it is called heat value or calorific value. It's a fuel property, so nothing to worry. For the fuel, that value will be given to you, so no need to remember heat value, they will give to you 42 megajoule, 44 megajoule, 43 megajoule, whatever the value they will tell you, so you use that value, okay, so nothing to worry here. Now in this thermal efficiency, if you concentrate here, it's a very simple one. What is the thermal efficiency you have written? It is 1 by 2 m dot a plus m dot f, which is the kinetic energy, rate of kinetic energy at the exit, minus rate of kinetic energy at the inlet, divided by m dot f into heat value hv. You know very well, if you take the common of m dot a, so what you will get? M dot a, it is nothing but 1 by 2, again I can small take middle bracket, so m dot a if you take common, so what will be the value? Value will be 1 plus mf divided by m dot a, okay, minus 1 by 2 v infinity square, and you can have this 1 by 2 common, so this value will be, bracket will be here. Hope you understood this. Now this m dot f you can take outside, so this is what heat value, and this m dot f you can take outside, yes or no? So r this value, which is nothing but, what is the m dot f? A by m dot f, actually m dot fuel air ratio, m dot f by m dot a is nothing but small f. So what is m dot a by m dot f? We know, okay, we know that uh, m dot f divided by m dot a, which is fuel to air ratio, it is called fuel to air ratio, and it is divided by small f. So this is just opposite, so it will be 1 upon small f, okay, into this bracket, and this is nothing but 1 by 2 in this bracket, what you will get? 1 plus small f, okay, and here also I think ve square I forget to write, right, ve square, so 1 plus f v square minus v infinity square divided by heat value. Agree with this? You know very well m dot a, m dot a is very greater value compared to m dot f, hence whatever the value of is small f, it is going to be a 0, yes or no? It is going to be 0. So but 1 by f you cannot say f is 0, so 1 by f will be infinite, okay, you cannot say like this. The reason is because, in fact, if you take 1 by f, because f is approximate 0, not exactly 0, I can take a small f is what, 0.92 something, okay, so 0.92 or you can f is I'm taking 0.001, just for example, f is I'm taking 0.001. What will be 1 upon 0.001? So it will give one value, yes or no? And it is 10 to power 3. So 1 by f will be the significant value. You cannot neglect that. My point is, yes or no? So here you can write this eta th thermal efficiency, and this value will be what? 1 by 2, and you can neglect f, so you will have VE square, and it is because 1 plus f is very small, so 1 plus something, it will be 1, so 1 into VE square will be VE square minus V into square. So I have removed few steps. Directly you can understand, f is very small, so I can neglect that. Here I can write, so this f you can neglect. Okay, so 1 plus 0 will be 1, 1 into VE square will be VE square here. Okay, now divided by, here you have m dot f by m dot a, which is nothing but f, so f into hv, f into hv. Okay, so finally eta ts will be ve square minus v infinity square divided by 2 times f hv. This is very important here. This is very, very important. Gate question they had asked based on it. Okay, see, all the points you need to concentrate. Okay, what is the important point here? Important point is eta th. Eta th is what? Directly proportional to v e infinity square minus v infinity square. This difference will give the thermal efficiency. If difference will be more, thermal efficiency will be less, because difference will be more in the sense, if VE and V infinity a gap, na? V infinity is very less and V is very high, so result will be more, so thermal efficiency will be more. If difference is less, thermal efficiency will be less. That you can understand in that way. Second, very important. Okay, second is eta th is inversely proportional to 1 upon f. That meaning is it is inversely proportional to you can say 1 by mf by m dot a, or you can say thermal efficiency is directly proportional to m dot a divided by m dot a. Okay, and thermal efficiency is hv, just opposite to quality of fuel. Okay, so this is the conclusion you need to remember. Okay, this is the conclusion you need to remember. Question they are asking based on it. When we'll solve previous year question, then we'll be able to understand. So please mark this table. This box is very important. This is what conclusion of eta th. Okay, for the gate. Remember it. It's very important actually. Sorry. All right. So this is the thermal efficiency. Similarly, you can write thermal efficiency for turbofan. Okay. So that I can give directly, just like propulsive efficiency I had given. So this thermal efficiency efficiency of turbofan engine. Okay, thermal efficiency of turbofan engine. So the similar way you have to derive whatever the formula I had given. So in the same way you can do. If you do that, because in turbofan you know very well there are two nozzles, cold nozzle and hot nozzles. You write all the velocity component. So here I am going to write it is nothing but VE hot square plus beta times VE cold square minus 1 plus beta V infinity square divided by 2 times of the fuel into heat value. Okay, VEH hot, you know that is exit velocity of the hot nozzle. VE cold means exit velocity of the cold nozzle. Beta I can write you. Beta is nothing but mass flow rate of the cold divided by mass flow rate of the hot nozzle. Alright. V infinity, you know, it is aircraft speed, you can say, or you can say free stream speed. Okay, so there should not be any confusion. This formula directly I have written. If question will be asked to you, you can directly answer by this formula. Okay, so this is the thermal efficiency of, even derivation is available. If you say I will send PDF, but I suggest I will attach, okay, that PDF, but I will suggest derivation is not important at all, not required. All right, so if you talk about the thermal efficiency for the turboprop, then how to write? So I will write the thermal efficiency of the turboprop also here. Thermal efficiency of turboprop, okay, and turboshaft engine and shaft engine. So what will be the formula here? The formula will be thermal efficiency is equal to SP divided by SP divided by m dot f into heat value. Okay, all right. What is the SP? It is called shaft power. Okay, it is called shaft power. So for both turboprop and turboshaft, this is the thermal efficiency formula. All right. Now we have a propeller efficiency if it is required for turboprop, propeller, sometimes required propeller efficiency. Okay, so propeller efficiency, it will be eta p r, propeller efficiency. Okay, how to get this? So propeller are basically used in two types of engine, you know that. Okay, piston and turboprop. In both cases, the shaft power is what converted into thrust power. What is the shaft power? It will be converted into thrust power, because whatever the thrust you are getting, it is because of the propeller. Okay, jet will not provide so much power, thrust power. It's like 80-20 contribution. Okay, 80-20 contribution. So always remember, whatever the power you will be getting, it will be because of the propeller. Okay, so what is the thrust generated by the a propeller. So better I will show the diagram so it will be more clear to you. Here propeller, or better I will write turboprop, so this part will be clear. Turboprop engine. So as I told you, turboprop engine piston is what outdated, you can say. Turboprop engine we are using for the commercial. So turboprop, there is the propeller, and whatever the thrust you are getting, it is because of the propeller only. And that physics of the propeller is what totally different what we had seen for the turbojet and turbofan. Okay, so in short, I will show the diagram so you can understand. But propeller concept is what totally different. Okay, but diagram I will show you so you will understand. Check. You can say this is what, as usual, you can say compressor, turbine. Okay, okay. Now this is connected. This is what turboprop. So basically, what I wanted to show you, this is called reduction gear. Okay, so we had seen turbojet, turbofan we had seen. Okay, we had not seen that turboprop engine. So separately, I will explain here turboprop. Okay, so in this turboprop we have a propeller. This is what propeller, and this is what reduction gear. It will control the speed of the propeller, and because it is connected with the assembly which is compressor and turbine, so that rotation sometimes may mismatch, so reduction gear will be there. Okay, that concept is totally different. And obviously this is what compressor. So this is what compressor. This is the combustion chamber CC. Okay, sorry. This is the combustion chamber up to here. And this is what turbine. Okay, and exhaust noise. But what is the how it is different from the turbojet and turbofan? It is different. Function of diffuser, you know, it will always use to convert kinetic energy into uh, here also diffuser we have. Okay, don't think we do not have diffuser. We have diffuser here. This is the diffuser part. Okay, it is small part, but it is. So what is the function of diffuser? You know that it will convert kinetic energy into pressure energy. That process will be same thing. Nozzle will use to convert pressure energy into kinetic energy. Okay, but here we are having the propeller, and this propeller, the angular velocity of the shaft is very high. Okay, and because propeller is what connected with the assembly, which is nothing but compressor and turbine. Okay, so the angular velocity of the shaft is very high, but the propeller cannot run at higher angular velocity because there is the aerodynamic losses. Because the propeller is what rotating with very high speed, and if it is approaching towards sonic speed, okay, or supersonic. So basically, if it is reaching to sonic speed, then somewhere there is the critical Mach number. So critical Mach number means what? Somewhere on the blade flow will be sonic flow, okay, and then the shock bubbles will start forming and shock will be formed. So because of that, there will be the aerodynamic losses, and the stalling chances of stalling of the flow from the blades will be there. So whatever the process, you have to maintain the maintenance of that speed of the propeller. I mean, propeller speed you cannot raise beyond the sonic speed. Otherwise, you may face aerodynamic losses. So sudden increment of drag and separation of the flow may occur over the blade. So obviously, the failure of the engine, you can say, you will lead towards the failure of the engine, right? That is the biggest problem. That's the reason this propeller engine will have a speed limitation. Okay, speed limitation in the sense only subsonic aircraft is what possible with the help of turboprop engine. Supersonic not possible. But turbojet, it is best for the supersonic. Turbofan also subsonic and supersonic both is, in both cases turbofan is good, but turboprop is what only for subsonic, okay, and less altitude. Always remember this is also used in commercial, but before now I told you that they also turbofan is what now in commercial 90% we are using because of that good feature in the sense both supersonic subsonic both are possible in case of the uh, turbopan. Anyway, so I mean both possible in case of turbojet also, but turbojet for subsonic speed and low altitude will not give good performance. That I had explained. So for that reason, there is the problem in turbojet. Problem in the sense you may have a loss of that thrust will be okay, but fuel consumption will be more at lower altitude and lower speed. That's the problem. Anyway, so this turboprop is very good, but it will be for the subsonic aircraft, subsonic flying aircraft. Okay, the reason is speed of the this propeller. So the angular velocity of the shaft is very high, but the propeller cannot run at higher angular velocity. So for that reason, we have a reduction gear. Okay. So what is the use of reduction box or reduction gearbox? The reduction gearbox will be providing the uh, or it will be controlling, okay, the speed. So the reduction gearbox is provided before the power is transmitted to the propeller. So whatever the power required to rotate the propeller up to what amount of the speed, that will be controlled by the reduction gear. Okay, that's the mean of it. That is called feathering. That is called feathering of the propeller. So that's the reason I said propeller itself a separate study. Okay, there is the feathering or that pitch control of the propeller. That is many things are there. We are not going into that because that is the totally different analysis of that. My point is turboprop engine is what constrained because of the speed of the propeller. Okay, and we cannot run this propeller with very high speed. So whatever the shaft we are having, that shaft is what transmitting the huge amount of the power. I mean, it can rotate with very high speed, but whatever propeller required, okay, that called the rating of the propeller. Okay, so based on that, it will rotate and it will be controlled by the reduction gear. For that reason, we are providing reduction gear before propeller. What means whatever the power we are transmitting from the turbine, okay, so it is not directly supplied to the propeller. In between there is the reduction gear, and that reduction, by word only you can understand reduction, so it will reduce the speed. I mean, it will match the speed with the good performance of the propeller. It will match, okay, because there is the rating. Okay, once you purchase any engine, they will give the rating for this voltage, this motor will be perfect. For this ampere of current, this motor will be perfect. Beyond that given rating, if you go, then it will not perform well. Okay, so same thing for the propeller also. If propeller design, so this propeller will have a rating. I mean, it is fixed for some particular range of the speed, and in that range, if this propeller will rotate, it will give good performance. And beyond the range, if it will rotate, then it will not give good performance. So that reduction gear will match the speed of the propeller, so that it can give maximum or optimize performance. That's my point. Okay, okay, so what I wanted to explain here, the point is, whatever the exhaust velocity we are getting, obviously, because combustion we have here. Okay, this is the combustion, so fuel you are burning and air will go enter here, so definitely here it will be m dot a plus m dot a. So, and here we'll have an exit velocity also at the same time. Then, but the thing is, in this exit velocity, it is not giving so much thrust. It is giving thrust like 20 to 30% only. Okay, 20 to 30%. Rest thrust will be generated by the propeller. Okay, rest thrust will be generated by the propeller. All right, and this propeller will be rotated by the turbine. That concept you know, because whatever the combustion occurs in combustion chamber, it will try to expand in turbine, and turbine will start rotating. It will be connected to the compressor as well as propeller also. So that power produced by the turbine, and that power will be transmitted with the help of shaft to the compressor and propeller. Okay, that concept you know. So now in one diagram I will show you, full diagram, so you will understand. So whatever the diagram, the diagram is C. Check. Okay, so the whatever the thrust you are getting, it is the air which is passing from the propeller. Okay, this is the amount of the thrust. I can say this is the amount of the thrust because of the hot air, means jet, and this is the amount of thrust produced by the air. You can relate in this way. So this is the air thrust. Okay, this is the air thrust. Air thrust means directly coming from the propeller, and this is what jet thrust. So you can imagine jet thrust will be very less in case of the turboprop. That my point to explain here. Okay. Anyway, for that reason, this turboprop will have a high propulsive efficiency. Anyway, so advantages for this is very I told you for lower altitude and for less speed this one is better actually, but the problem is what, it cannot fly supersonic. Okay, only for subsonic it is better. So what is the advantages? Advantages are many, like high takeoff thrust you can say, because first that propeller will start rotating. Okay, so once it will get, how that thrust will be produced, see, you can say this is the concept of the propeller only, but that I am not going to explain, but I can tell you this P1 is the supposed pressure here, okay, over this blade, that is ahead to the propeller. Okay, and behind to the propeller the pressure is nothing but, behind to the propeller the pressure is nothing but P2, and P2 is always greater than P1. So thrust will be exerted, okay, over the propeller, just like in your fan, ceiling fan you can say. This is the vertical plane. Ceiling fan is what, on your horizontal plane, just like ceiling fan and table fan. Check table fan, how that air is what blowing. It is sucking air from backside and throwing air in front of you. Okay. So if it is very high speed, then it becomes thrust. So this P2 will be very high. So P2 uh, will give the pressure thrust, and it will be in forward direction. It will be in forward direction. Okay. So P2 minus P1, that pressure will be exerted in forward direction into area, disk area. This propeller will be treated as a disk. So that disk area into pressure will give the pressure thrust, and it will move in forward direction. So that theory is what propeller theory, which is totally different. We are talking here about jet engine, and also our focus is what, not propeller theory. We have to talk the things related to thrust and SFC and all. Anyway, but here I have explained. So the good propeller efficiency at a speed below 800 kilometer per hour. Okay, reduced vibration and noise, better fuel economy, because you are burning less amount of fuel in combustion chamber, because more and more thrust you are getting from the propeller. So obviously fuel economy will be better, and that will be the first priority. Okay, easy maintenance will be easy if you check turbofan. And also in turbofan, see the blades, fan blades are inside the cowling, and many blades are available in fan. So if you go for maintenance, it is very difficult, but here propeller blade, highly 2 or 3 blades will be there. Okay, so that maintenance will be easy compared to others. It operates over a wide range of speed due to multi-shaft arrangement. The power output is not limited. Okay, sudden decrease of speed is possible by thrust reversal. Okay, you can, because in propeller also that thrust reduction you can do. If you change the angle of blade, then whatever the thrust you can increase or decrease. Okay, disadvantages for the propeller engine, again there are many points, few points I will tell you. Like the main disadvantage is the propeller efficiency is rapidly decreasing at high speed due to shock and flow separation, that I told you. That is the biggest disadvantage of turboprop. Okay, so if you go for very high speed, so that time there is the efficiency of the propeller will decrease rapidly due to shock formation and flow separation. Okay, so that's the reason this turboprop engine aircraft will fly at lower speed in subsonic condition. It requires a reduction gear, which increases the cost of the engine, and obviously weight of, because this reduction gear is very heavy actually in a weight. So unnecessary, the size and weight is what increasing, because you are flying in, atmosphere, in air. So what possible weight you can reduce, but this is the extra part you are getting reduction gear in case of turboprop compared to other engines. Okay, and obviously more space needed than turbojet engine. Why? Because of this propeller blade. So that's the reason that they also, I told you, turboprop you can say lower, turbojet is extreme upper, turboprop is extreme lower. In between, the best suited engine is turbofan. So what was the disadvantages in turboprop engine? We have modified And what was the disadvantages in turbojet? We had modified and we optimized, and then we got new engine called turbofan engine, that already you have seen. Okay, so finally here we have completed this turboprop also. Okay, so if you write propeller efficiency here, so because now propeller efficiency for the turboprop is what important now, might be understood why it is important. I have explained because the whole thing is what depending on this propeller blade only. Yes or no? So if you write the propeller efficiency eta PR, what is the propeller efficiency? It is nothing but eta PR. Till now they have not asked propeller efficiency and all, but sometimes if they will ask, then you need to answer it, or the concept you should know, because advantages and disadvantages based question they are asking. Okay, theory question they are asking. So now hope you understood that propeller turbo, this turboprop engine is what compared to turbojet, propulsive efficiency will be good, thermal efficiency will be good compared to turbojet. I am saying, okay, compared to turbojet. So what is the propeller efficiency? I can say propeller efficiency is nothing but thrust power divided by shaft power. Divided by shaft power. What is the thrust power generated by thrust power? Thrust power. Thrust power generated by propeller. It is nothing but thrust power generated by the propeller TP, which is nothing but thrust produced by the propeller into the speed of the aircraft v infinity. Okay, and shaft power as usual, it will be given to you. So eta PR is nothing but TPR. This is the TPR. TPR means thrust produced by propeller. PR means propeller v infinity divided by SP, which is nothing but shaft power. So that value will be given to you. Now we'll go for the overall efficiency. So what is the overall efficiency? Overall efficiency, it is nothing but eta O. So what is the overall efficiency? So eta O is nothing but overall efficiency. It is thermal efficiency into propulsive efficiency, that you should know. So for all type of engine, thermal efficiency and propulsive efficiency you have here. Okay, so you can calculate this. TPR, if you check here, again I will tell you, this TPR is nothing but thrust produced by propeller. I told you propeller, there is the propeller theory, okay? Propeller theory, and in that formula will be available. It is one derivation, how to get thrust from the propeller. So propeller theory is available, okay? But in examination, they will not ask propeller theory or something. They will give the value thrust power, okay? Nothing to worry. We'll solve problems, you may get idea. So overall efficiency you have written. All right, now we'll go for the take-off thrust. So what is the take-off thrust? That is very important, and one time question also they have asked. So take-off thrust. Take-off thrust, this is also one very important parameters, performance parameters of the aircraft. Okay. Just like we had seen the advantages and disadvantages, like for turboprop takeoff thrust is good. So what is the takeoff thrust? That we should know. So takeoff thrust is basically what is the mean of the takeoff thrust? Takeoff thrust is an important parameter that defines the ability of an aero engine to provide a static and low speed thrust. Okay. that enables the aircraft to take off under its own power. Okay, because all the engine here, see, shaft power, don't bother about the shaft power. Shaft power, there is no formula to calculate. Okay, shaft power. Once the machine will be designed, so shaft power will be given to you. Yeah? So this SP is nothing but shaft power. So they will tell you for the engine shaft power is this much amount. Okay. So nothing to worry. The value will be given to you. Shaft power. Take off thrust. So as why this is important parameters, because any for any aero engines, this is the takeoff thrust is defined the ability of aero engine to provide a static and low speed thrust. Okay, and because of this thrust only, that aircraft will able to take off under its own power. Okay, so that's the reason takeoff thrust will be used for the as a performance parameter. At 10 kilometer what is the altitude, at 10 kilometer altitude what is the thrust, that is okay, that is one parameter, it's okay. But at the takeoff time, which engine is giving good thrust, that engine you will use, right? So because at that during the even takeoff, that velocity is what very less. Even at 10 kilometer altitude, definitely velocity you will have, because that time will be the cruising condition, and cruise condition you will have a maximum velocity. But during takeoff, velocity is very less, and thrust is nothing but the function of velocity will be less, the thrust will be less. Then what is the minimum thrust required to take off, or what is the thrust required to enable the proper takeoff condition? Okay, is the takeoff thrust. Okay, like you have seen turbojet, turbofan and turboprop, both all three are having their own takeoff thrust. But come to ramjet and scramjet, that ramjet and scramjet engines, they do not have that takeoff thrust, they don't have a static thrust, you can say. So for that reason only, ramjet engine will be launched by some other device or some other aircraft, it will be launched. There is that ramjet cannot fly from the ground. That ramjet engine aircraft will be launched at some altitude with some speed, because they do not have a static thrust. So that's the reason I told you static thrust is very important. Okay, and this takeoff thrust is nothing but a static thrust basically. So always remember, takeoff thrust is defined the ability of aero engines, okay, to provide static and low speed thrust, so that aircraft will enable to take off under its own power condition. Okay, so I must say static thrust, if I will mention static thrust, static thrust. Okay, so for the static thrust condition, if you say, then that's meaning is what, aircraft is what, static, which is nothing but zero velocity, aircraft speed will be zero, v infinity is zero, means what, aircraft speed will be what, zero, because it is just going to going, this is the static thrust, the word you can understand, static means stationary condition, that aircraft speed is what, zero. Okay, so how to write this takeoff formula? So it is, you can say you have thermal efficiency, and what is the thermal efficiency? Thermal efficiency, you had seen thermal efficiency we had derived, and it was 1 by 2. Previously we had derived m dot a plus m dot f. Okay, and it was ve square minus v infinity square into m dot a, if I am not wrong, divided by m dot f into hv. We had seen this was the formula previously, thermal efficiency formula. So check, this was the formula only, thermal efficiency. All right, 1 by 2. Huh? This was the formula, 1 by 2 will be common. So this was the formula. Now in case of the takeoff thrust, if you are going to calculate, so static thrust condition, you will have a V infinity uh, which is nothing but 0. V infinity will be 0, hence you can make this, because you are going to write takeoff thrust, so definitely this V infinity must be 0. So what you will have? You will have m dot, we can take common m dot a, so what you will have, 1 plus mf by m dot a into v exit square divided by 2 times m dot f into hv. So this eta th is nothing but m dot a, m dot a 1 plus small f v exit square divided by 2 times m dot f into hv. We can say this. Okay. Now I can say this is the equation number 1. Now what is the thrust formula? Thrust is nothing but, you know, m dot a in bracket, it is nothing but, you need to write complete formula. What is the thrust formula I'm talking about? Because if you say static thrust, so static means what? Two conditions need to write. First, velocity will be 0, and second, it will be the PE is equal to PA, because it is static condition, you can say. So obviously exit pressure will be atmospheric pressure approximate. So pressure thrust already becomes 0. So what will be the formula? The formula will be m dot a plus momentum thrust into VE minus m dot a into V infinity plus PE minus P infinity into area. Yes or no? So if you check for the static thrust, this part will be 0 because it is equal, and this velocity component will be 0. So take off thrust or static thrust, you can say, it is nothing but m dot a plus m dot f by m dot a into VE, which means m dot a 1 plus f into VE. This is nothing but takeoff. This is equation number 2. Check equation 1 and 2. See, somewhere m dot a 1 plus f we have into VE square. Instead of that, what we can write? We can write takeoff thrust. We can write or not? Check what is the eta th now. We have eta th. Check what is the eta th. It is m dot a 1 plus f into VE square. M dot a 1 plus f into VE square divided by 2 m dot f, 2 m dot f into hv, 2 m dot f hv. What we can write? M dot a 1 plus f VE into VE 2 m dot f into hv. What is the eta th? Check m dot a 1 plus f, this value. This is nothing but takeoff thrust. So you can write okay. So what is the takeoff thrust? Takeoff thrust is nothing but 2 m dot f. Okay. Eta th hv divided by V. Great question they had asked based on this. Why I have derived these steps? Because great one time great question they had asked. They had asked it from here. Okay. What they had asked, I will write. T take off. What formula you got here? 2 times F eta th HB divided by VE. See what are the points? Check. The points are T take off thrust is directly proportional to m dot f. Okay. Again, T take off 1 by exit velocity. T take off directly proportional to thermal efficiency. T take off is directly proportional to heat value. All points you need to write, okay? And remember, they had asked this one. Anything they can ask. Anything they can ask. Here now the result is what in front of you. Okay, takeoff thrust. Now by getting this 4 point, now you can answer which engine will provide maximum takeoff thrust. So if you check here, takeoff thrust is directly proportional to mass flow rate of the fuel. It's a fuel, right? Mass flow rate of fuel or it's air? Let me check. Mass flow rate of the fuel. Okay. Anyway, so exit velocity eta th. But the aircraft which is having lowest exit velocity or exhaust velocity will give maximum takeoff thrust. So I explained just now here turboprop. Check this turboprop. This exhaust velocity here is less, then only you are getting less thrust by jet only. Whatever the thrust you are getting because of the propeller. So for that reason, the turboprop engine will have high takeoff thrust. Okay, that is the advantage of turboprop actually. All right, fine. So this part is what done. Now we'll go for the next one, performance parameter, which is nothing but specific fuel consumption. What it is called? A specific fuel consumption, which is very important. Which is very important. A specific fuel consumption. It is called SFC. This is the very important parameters of the jet engine. Okay. A specific fuel consumption you can understand by the word only. Right. fuel consumption. So the fuel consumption is either defined per unit thrust force, okay, or per horsepower. Horsepower for what? Horsepower for the turboprop and piston propeller, and defined fuel defined per unit thrust will be for the turbojet, turbofan and ramjet. So the meaning is whatever the amount of the fuel burned in combustion chamber per unit thrust. Okay, like in simple word I can say, if 2 liter of the fuel you are burning to get 20 kilonewton of thrust. If this calculation you are doing, then this is called a specific fuel consumption. So mass flow rate of the fuel per unit thrust. I mean, if you are burning 1 liter of amount of the fuel, then what amount of thrust you are getting after burning of that fuel in combustion chamber? What amount of thrust you are getting? That ratio will be called as specific fuel consumption. Hope you understood. So specific fuel consumption is very important parameter actually. Why it is important? Because for the aircraft, even for your bike or your car, you always calculate, okay, if I'm filling 1 liter or 2 liter or 5 liter petrol or 1 liter, just basic 1 liter petrol, then at what distance this bike or car can travel. In 1 liter it is going 60 kilometer, 30 kilometer. In our automobiles it is called mileage. Yes or no? It is called mileage because we are interested in distance, not in thrust. What is the mean of thrust in car and bike? Nothing. That in our interest is distance. If we are filling 1 liter petrol, then it is going 60 kilometers, so I will say this is the mileage of the bike or car. So in the world of aviation, for the aircraft, the same mileage, just like for the automobiles, I told you in 1 liter it is going 60 kilometer, so it is mileage, okay, automobiles. But if I'm saying m dot f, which is nothing but mass flow rate of the fuel, I can say 10 liter per second if I'm burning, then what thrust it is producing, it is called specific fuel consumption. I hope this one is very clear to you now. Okay, so this is the very important performance parameter, so I must write here the fuel consumption. Fuel consumption, okay, per unit thrust, or fuel consumption per unit horsepower, or per unit power I must say, okay, per unit power. Fuel consumption per unit thrust or fuel consumption per unit power. If fuel consumption per unit thrust, then it is called specific fuel thrust specific fuel consumption, I can say. And if it is power, then we can say power is specific fuel consumption. When I explain range and endurance, that time I had given this TSFC and ESFC. So TSFC is called thrust specific fuel consumption, okay, and PSFC is nothing but power specific fuel consumption, okay. Obviously thrust producing engine is what? Turbojet, okay. turbofan, ramjet. Power producing is what? Turboprop, turboprop, turbosaft. All right. So now it is very clear. What is the thrust? So here I'm considering most of consideration is what for jet and turbojet and turbofan. Okay. So instead of TSFC, I will use word SFC. Okay, SFC. And if I'm using thrust, then it will be thrust is specific. And if I'm using power, then it will be PSFC. Power engine or thrust engine, only two types of engine we have. So if I say, or sometimes power engine also consider PSFC, or you can say BSFC. What is BSFC? BSFC is called brake specific. Brake power, you might have heard. Brake power, horsepower, brake power. No? So that is related to power. So that is not our concentration. I must say SFC is nothing but specific fuel consumption is m dot f, mass flow rate of the fuel per unit thrust. What is the amount of thrust you are getting after burning 10 kg per second of the fuel? What amount of thrust you are getting from the engine called specific fuel consumption. Okay, this is very important parameters. Gate problems, even they are asking based on this SFC, they will ask to you. Okay, so that you need to remember. So as I told you, SFC or thrust specific fuel consumption meaning is same. It will be used for ramjet engine, turbojet engine, turbofan engine, and the next engine is uh, 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 power based engine like turboprop, piston propeller engine. So for that you can use uh, uh, PSFC, power specific fuel consumption, or in few books you may get BSFC, brake specific fuel consumption. So that formula will be m dot f divided by P, which is power, and power is what? Shaft power. Yeah? All right. So this is related to SFC. Now I'm going for this SFC also need to concentrate. They can ask question based on this point one. Is SFC is what? Increasing fuel you are burning more. SFC is what? Also reciprocal to thrust. So the if any engine where mass flow rate of fuel is what required more, or you can see if you are burning more fuel like ramjet engine. In ramjet engine you will burn more and more amount of the fuel. So SFC will be high. For that reason SFC is very high, then it is very costly for us because fuel economy will not be good, right? If you are burning more amount of fuel, it means fuel economy is not good. So these 2 points you need to remember. Then last one, I think in performance parameter, it will be the specific thrust. So let me complete that also. So the next one is the specific thrust. Specific thrust. So generally specific thrust will be denoted by F. Cohen and Roger, I am saying FS. FS is nothing but specific thrust. Okay. So what is the mean of this? So very simple. A specific thrust, it is said like you have heard a specific energy, right? A specific volume. So similarly, we have a specific thrust here. So what is the specific thrust? The specific thrust is nothing but defined as the thrust per unit mass flow rate of air. How it is defined? It is defined as the specific thrust is defined as thrust produced by the engine, thrust produced by the engine, thrust produced by the engine, or thrust divided by mass flow rate of air. Mass thrust produced divided by mass flow rate of air. In general, what is the thrust produced? Fs is equal to, what is the thrust produced? What is the thrust produced? It is nothing but, if I small f, which is the fuel air ratio, I have neglected, so it will be m dot a ve minus v infinity divided by mass flow rate of the air m dot a. It is nothing but ve minus v infinity. Okay, this is very important. This is very important. Okay, this formula need to write. Generally, thrust is formula I told you. Thrust is m dot a in bracket 1 plus f ve minus v infinity. I told you because whatever the fuel we have here, small f, it is nothing but m dot f by m dot a. So this value is what most of time 0 I can consider. Why? Because m dot a is greater and greater of m dot f. You can say the combination, I will say, like 50 kg per second air and 1 kg per second is what fuel. So consider 50 and 1, big difference. So m dot a is very greater than m dot f, hence small f will be very small. I can consider 0. So what is the specific thrust? It is nothing but ve minus v infinity. Check what will be the specific thrust of turboprop engine. It is very less. Why? Because exit velocity is very less. Because exit velocity is very less. Yes or no? But in case of turbojet, what is the specific thrust? It is very high because exit velocity is very high. If it is flying Mach 2, Mach 3, Mach 4 turbojet engine, so you can imagine exit velocity will be very high. Yes or no? So the thrust developed per unit mass flow rate of air is known as a specific thrust. And generally, this provides an indication of the relative size of the engine producing the same thrust because the dimension of the engine are primarily defined by the airflow. Okay, and at the same time, it is also defined the degree of exhaust velocity. If exhaust velocity is very high, then specific thrust will be very high. If exhaust velocity is very less, then specific thrust will be very less. So that's the one thing. Okay, fine. Now we'll go for the non-dimensional thrust. This is one more performance parameter. Non-dimensional non-dimensional thrust. What is the non-dimensional thrust? Simple. Whatever the non-dimensional thrust, directly better you write the formula. It will be defined as T naught. But T naught may you may understand total temperature. So better I will give another non-dimensional thrust. How can you notation? I can say NDT, non-dimensional thrust. Okay, NDT. It is nothing but thrust divided by speed of sound. Thrust divided by speed of sound. This is nothing but non-dimensional thrust. It will be denoted by NDT. If it is asked, you answer it. Okay. You need to remember this is the non-dimensional thrust. All right. Non-dimensional thrust. Thrust divided by speed of sound, which means T divided by A. T divided by A. This is called non-dimensional thrust. Okay. One more last analysis we have left. So it will take hardly 10 minutes. So we'll complete that also. That condition is called thrust power. but what is the condition of to get maximum thrust power? That is the analysis here. Okay, and the and what is the propulsive efficiency at maximum thrust power condition? That is the analysis. All right. So I can say here the thrust power is nothing but condition of maximum thrust power. Okay, how to get it? What is the thrust power? So thrust power is nothing but will be denoted by PT, better P for power, T for thrust, so it becomes thrust power. What is the thrust power? PT. Power, what is the power? It is force into velocity. What is the force? It is nothing but thrust. What is the velocity? Velocity of aircraft. Yes or no? So what is the thrust formula? We know thrust formula is nothing but m dot a ve minus v infinity into v infinity, right? We can write this m dot a, and we can take v infinity common. Okay, if we'll take v infinity common, so what we'll get? V infinity common, then it will be ve uh, aircraft speed by v infinity by ve was alpha, right? So we'll take ve common, no? We'll take ve common because I just want to write in the format of alpha. So if you remember, alpha was the aircraft speed divided by exhaust speed. So here this is nothing but ve you take common, so it will be 1 minus v infinity divided by ve into v infinity. So what will have? PT is equal to thrust power is equal to m dot a. Okay, if you take ve common here, so ve taken common, so what you will have? 1 minus v infinity, 1 minus v infinity by ve, and here you have v infinity. So again you multiply it and divide by ve, so again one more v infinity by ve you will get. So multiply and divide, so ve, multiply and divide, so what you will have? M dot a ve into ve square, in bracket what you will have? 1 minus, this is nothing but alpha, and outside also one more alpha will have. Okay, outside also you will have one more alpha. So this is nothing but, check, this is nothing but m dot a into ve square. Okay, and we can write alpha minus alpha square. This is PT. All right, always remember this is the PT. This is also one formula. Always remember thrust power formula. Now I'm interested in to get maximum thrust power. What you will get? Maximum thrust power. What is the value? PT max. How you will get? You have to take derivative of this thrust power divided by, take derivative with respect to what is the variable thing? You can say variable is what? If tit is fixed, v infinity is fixed, so alpha is the variable because alpha is nothing but v infinity by ve, so that aircraft speed can increase or decrease, so we have to take alpha as a variable, and write differentiation and make it equal to 0. So what will be the derivative check? What is the bracket part only? M dot A into V is what constant you can say. So if you take derivative of that bracket part, so you will have d by d alpha of alpha minus alpha square and make it equal to 0. So what you will have 1 minus 2 alpha is equal to 0. What is alpha? This is 1 by 2. This is very important. This is asked in your exam. This is asked in your exam. What is the conclusion here? Check. What is the conclusion? What is the conclusion? Conclusion is very important. What is that? At maximum thrust power. No? You got alpha is equal to 1 by 2 at maximum thrust power, PT max. Alpha is equal to 1 by 2. What is alpha? V infinity by V is equal to 1 by 2 or V is equal to 2V V infinity. Okay. They have asked. Okay. So this is the gate question. This value they have asked. Okay. When you will get maximum thrust power. So this exit velocity is equal to 2 times of aircraft velocity, right? When you will get this at one important condition, and what is the condition? At maximum thrust power. Next, this is the completed only. What is the propulsive efficiency? Propulsive efficiency at maximum thrust power. What is that? Eta P at what condition? PT max is the 2 alpha divided by 1 plus alpha. 2 into what is the alpha here? You calculated. Alpha is 1 by 2. Alpha is 1 by 2. 1 plus 1 by 2. So here you can say eta P at TP max 2 into 1 by 2 divided by 1 plus 1 by 2. It is nothing but 1 divided by 3 by 2. This value also they had asked in exam. What is this value? 2 by 3. Calculate. I think it's 0.66. No? In percentage it is nothing but 0.66, and in percentage if you say 66.66 0.66.6%. This is the value they had asked in exam. Okay, done.